So I'm going to introduce our next guest. Dr. Jason Corso is a professor of electrical engineering and computer science at the University of Michigan, and he's the co-founder and CEO of Voxel 51, which is an AI software company creating dev tools for improving the performance of computer vision and machine learning systems. A veteran in the field of computer vision, Jason has dedicated over 20 years to academic research and has authored nearly 150 peer-reviewed papers and hundreds of thousands of lines of open source code on computer vision, robotics, data science, and general computing. Prior to the University of Michigan, he was a member of the computer science and engineering faculty at SUNY Buffalo and spent 2 years prior to that as a postdoctoral fellow at the University of California, Los Angeles. He received his PhD and MSc degrees from the Johns Hopkins University and his bachelor's degree with honors from Loyola University, Maryland, all in computer science. Please welcome Dr. Jason.
Thank you very much. It's a pleasure to be here, Shilpi.
Thank you, Jason.
Before I start talking, could I ask you how I'll control, or do you control the slides?
We have enabled sharing, so if you want to do that, that's fine. I also have it. So do you want to do it?
Oh, I'll share. Let's see if I can do that effectively.
I have your slides. So, okay, either way.
Are you able to see the slide?
Yes, we are.
Wonderful. Okay, great. Let's put that down there. Yeah, it's a pleasure to be here. I'm really, truly honored to be talking at this data ethics summit. I think it's a exceptionally critical topic, and I think we should think of this as the beginning of an important conversation that will continue for some time. So as you know, I mean, we're here, AI is everywhere, rampant across different domains, from finance to space travel to defense to banking to healthcare to education. It's almost daunting what we think AI can do for us, driven by data and learnings and so on, and the critical need to take a pause and understand what are its limitations and what do we need to think carefully about in order to achieve such potential without extra bias or other concerns or limitations of the resulting systems. So in our view, we think of better data leads to better models or better AI systems. It's exceptionally important to build data sets that you've sifted through, that you've tested, that you understand any intrinsic or implicit bias in those data sets. And it's exceptionally challenging. As a quantitative example, I'm a technical person myself. Let's look at the graph on the right side of the slide here. So on the horizontal axis, we see an increasing size of a data set going from 20,000 samples to 50,000 samples. This is actually sampled from a common data set called CFAR10. And on the vertical side is the accuracy on a test set, here called a validation set. There are three curves that are plotted. The blue curve, which is de facto not doing anything special with your data. The green curve, which is best possible if your data is perfect. And the red curve is what you do when you look at the data and get close to the data and fix mistakes you find in the data. And so here the mistakes are artificial. So I've added something like 10% erroneous labels in the classification data set. But you can see that if you're able to find and fix your data, those mistakes in your data set, you can get far better performance of your ultimate model. That's the type of quantitative thing we want to reach when we're building AI systems and machine learning models. And as you're aware, like as we're building these systems, there will be a loop, right? We'll start with some problem, we'll feed that into some data acquisition, we'll label the data, we'll understand data privacy, data provenance, and so on. We'll push that data forward to models. And when I say models here, I mean like training models, experimentation, tracking, and so on. And then ultimately we'll have a loop in which either we'll do some analysis on our output how did the model that we trained perform on some other holdout data set or some other data set, or we'll actually just do the loop without analysis, which is somewhat common, unfortunately, these days. The analysis part is super critical to this need, and that's where you really will get, where you really touch the data and understand what's happening, what subsets of the data are limited, where do you need to get more data, where are your annotations incorrect, and so on. And so one example that's relevant to this meeting here is about predictive policing. A few years ago, we worked with the Baltimore City Police Department and the City Watch program to understand how video analytics could be integrated into helping to get the right data to the right people at the right time. This was all in pilot, nothing was deployed. This was really to understand the limitations and capabilities of contemporary video analytics for allocating, not so much in predictive policing, but in responsive policing. And so we were thinking about what are the technical problems and the real world problems of processing video information rapidly to keep people safe and so on. In City Watch in Baltimore, I think they have upwards of 800 cameras that need to be concurrently processed, but a limited compute budget to do that. So this was a good technical problem. There was a lot of video, it was streaming video. They had a small team of humans to look at the video and so on, but of course couldn't always have everyone looking at 50 videos at once, right? So we had the idea was, could we sort the video in a way that their humans could then go and process, their officers could then go and process the video to understand how to respond to events, right? So clearly here is how could we avoid bias? If every officer that's watching the video had to monitor 50 feeds, we were going to show them the top 5 of those. How could we avoid bias across that? We wanted to do that in ways that would, again, get the right data to the right people at the right time, without avoiding bias, right? So in this video here that you're seeing here, if we're able to detect a fight that's going to break out or may break out or that kind of thing, could we do this in a way that is not biased to the location of the camera, for example, which I don't believe is a good indicator for this type of signal, or the type of behaviors that are being seen, or the type of persons in the video. So here there was actually a fight that turned into an argument, ultimately led to, as we learned later, an arrest and so on. But this was all previously captured video, but it's a good type of example where we need to make sure that when we think it's a fight breaking out, that we test our data, our models on real data, and understand how they might actually perform. Right, and so in my view, right, to train better ML AI models, it's super critical to visually inspect the data, and so that we can understand the diversity, the representativeness that data set has. And we also need a way to understand what subsets of data our model will perform well or perform poorly on, right? So where do we have high uncertainty or low uncertainty? In order to do this, we need adequate tooling to enable rapid, what we call rapid data set experimentation. Right, and so here are some tools. I think this is recorded great, so you'll have this capture. But here are some open source tools that flesh out this cycle, the machine learning life cycle here. And one that I'll talk about a little bit more is in the bottom right here, which is our tool from Voxel 51 called 51, which really allows you to do performance visualization. So it really fleshes out this notion of analysis so that you can achieve the types of things that we were talking about here. So visual inspection to understand rapid data set experimentation, right? So 51 is a tool that helps data scientists choose their optimal samples, remove redundant images, find annotation mistakes, bootstrap better training data sets, all the things that we do now, but it takes a laborious time to do it because there's no one common, easy, lightweight tool to do it. And 51 really steps up to do that. It has a visual interface that you're seeing a screenshot of here on the right side, as well as a tight bridge to an underlying Python library that you can use while doing model development work or Python coding and so on. The actual labels or the ontology that you're using to visualize and test your data set is fully flexible up to how you represent your data. And it's really important to note that through these tools, you can do things like, for example, identifying failure modes in your data sets rather quickly through visual inspection, right? So you've loaded a data set into Python, you launch the app through a couple lines of code, and then you're able to plot your predictions. Oh wait, there's too many predictions. What's the right confidence threshold I should be using, for example? Or how are my predictions? So in this case, red are ground truth, blue are predictions. How are those predictions representative of what the human gold standard or the ground truth was? Very, very quickly and naturally to do that. Right, so it lets you dig deep into data samples as well. So if you were to click on one of those images, you'll bring up a zoomed in version of one of the images here, and you're seeing lots of relevant information like the IOU scores, where the object detections are being labeled and detected and so on. And then you can turn different elements on or off for really dynamic. It almost, in my view, it kind of creates like a visual query language that lets you really manipulate and work with your data naturally so that you can build better data sets, right? So a lot of flexibility. So it supports classification problems, 2D object detection problems, instance segmentation, semantic segmentation. It does handle image data, and in a week or two, it will be handling video data. So it's really interesting in terms of the future potential use of the tool here. And one final note, it has a very intuitive and extensible API. So as Shilpi may have mentioned, we will be available for people in the next few days at the hackathon that's associated with this meeting to provide support. This tool basically meets the need to visualize and sort of render what's happening in your various systems. And the API itself is exceptionally well documented. And supports, so it has a schema-free data model. So you don't have to laboriously go through SQL queries and meta language and so on. It's very adaptive. It sits on top of MongoDB. It supports arbitrary user-defined fields that are also immediately rendered in the GUI. It has no data set size limitations. It also doesn't copy your data set into some central data store. Runs on your machine, connects right to your data where your data is. And again, there's a real tight connection between the code and the UI. So again, 51 is a great data set exploration tool that enables you to, let's go right back here, to really tighten the speed or the iteration on this AI system development. It is open source, an Apache license, so no cost associated with it, and connects really well with things like TensorFlow, PyTorch. We use it in our own development in connection with, say, like MLflow is an experiment tracking tool, and it supports on the order of a dozen different annotation formats. So it's really flexible, and if the mission is to get closer to your data so you understand what are intrinsic biases or limitations of that data, well, this 51 tool has been designed from the ground up to enable that, which we think of really as like the responsibility of the data scientist or the AI scientist when we are building models that will be deployed in practice and impact society. Thanks for your attention. If there's a question or two, I'm happy to take it.
Thank you, Jason. This was really inspiring and interesting. I want to quickly add to what you already mentioned. It is in the agenda, it is on the community platform, it is on the main website, but I just want to add to what Jason just said. We do have a very exciting boot camp taught by Eric Huffsman tomorrow at from 3:30 to 4:30, and it will be around, he'll be doing a hands-on workshop on how 51 works and how it can be used for visualization and analysis of image data, something that you can use for the 48-hour hackathon coming up front on Saturday and Sunday. So thank you. Really excited about the bootcamp and the workshop, Jason.
Great. We are too. Yeah, it's wonderful.
Thank you. And I don't see any, oh, there is a question, Jason. Can you bring in your own libraries or just the preferred ones?
Could you elaborate on that question? So
predefined, or just predefined. So you have scikit-learn. I saw Spark on there. Are there other libraries if you want to be able to bring in on this, or is that still, or are you using just those?
Yeah, I think there's no limitation at all, actually, on what libraries you could use to support. So, like, say you have a data set you're using scikit-learn like an SVM or something like that from scikit-learn, and you get your classifications on your images. It's natural, kind of like 1, 2, 3, to add a scalar field to the representation in the 51 data set and then render that on the GUI. It's kind of built to be really lightweight and connect to your workflow. I guess that said, the only constraint is that it's really for visual data right now. So it doesn't support, say, audio data or language data or tabular data, things like that, but really for image and visual data. And I think it'll be really good to listen to the bootcamp tomorrow with Eric. So he'll walk you through lots of examples that do the types of things that you're asking about.
Yeah, I think this is interesting because predictive policing uses a lot of image recognition technology, which is one of the challenges for our hackathon. And that's all image recognition, right? So Voxel is very useful in that.
Yeah, it looks like there's another question too about customers. So great question. So we have so 51's a developer tool. That's an open core tool, right? So open source. We launched it in early August, so it's pretty young. It's been in development since just before COVID. It was actually built on top of our internal libraries when we were doing the video analytics work I talked about with Baltimore Police. So kind of was built from our own experience. Let's see, so right now we have a Slack community that has about 150 users in it. There are everyone from academics to major corporations. There's some members in the Slack community from Lego, among some other companies, for example. Being open core tech, we're not selling licenses to it right now, so we don't track the users exceptionally well. In the future, for things like connecting to your data in vast data lakes in the cloud, things like that, sharing across teams, large-scale backend compute. That's the type of stuff that we're building that will be commercializable on top of this open source library. But right now, the open source library runs. There are no constraints on the size of the data or how much compute you connect to it locally if you're able to do that. So yeah, good question.
Great, thank you, Dr. Jason. Take care.
Thank you. Bye.
Bye.